What is up, math superstars? In this edition of Mr. Peterson Presents, we are bringing to you probability. So in probability, in this lesson, we're going to talk about the effects of independent and dependent events. So when you have more than one event, the events that happen, so the 2 games that we're playing, the 3 games that we're playing, the different things that are happening in this game, the events, either they have an effect on each other or they do not. So the ones that affect each other, they're called dependent events. So these events, they have an effect on each other. And so say if we have a deck of playing cards, and say you want to do 2 different guesses of playing cards, you take one out, but then you keep it out. So that affects what's going to happen in the second event. So this is used, so you want to highlight this in your notes. So these will have a statement in them that tells you that you do not replace what you took out of the first event. But if we have independent events, these are events that will not affect each other. So these statements, these will have statements that say or imply has with replacement. So what we're saying is, to do round 2 of the game, we're going to put back in everything to make sure that they don't have an effect on each other. Another way the 2 independent events happen, it might be that you play, you roll some dice, and then you have a spinner, and so your dice have no effect on the spinner. We could say that these are independent events. So let's go ahead and take a look at 2 examples here. And so, in example number 1, it says, I have a bag that has 4 red marbles and 3 green marbles. So we have some information here. So let's go and underline some information. We have 4 red marbles. Let's actually use red for my underlining. And then I have 3 green marbles. Let's underline that in green. So what's the probability that I'm going to pull a red marble first? Red marble. And then you have this phrase right here, replace it. And then I'm going to pull a green marble. So what type of event is this? Is this going to be dependent or independent? And so if I'm going to replace it, anytime that I'm replacing it, this is called an independent event. This is the type of event that the first selection, me picking a red marble, has no effect on the green marble. So here's how this is going to look mathematically. So if I'm going to pull a red marble here, I'm going to write this as the fraction with a denominator of 7. There are 7 total marbles here, but there are 4 red marbles. So my probability of me pulling a red marble the first time is 4/7. But I also have this probability of a green marble, because the second event is I need to pull a green marble. So the green marble, the denominator is still going to be 7 because I replaced the first marble I used. So there's still 7 in the bag. And I have 3 marbles here. And what we have to do now is we have to combine these 2 events together. And so we have 4/7. And anytime we combine 2 events here, probability, we're going to be multiplying. And we're going to multiply it by 3/7. And that's going to equal, so we're going to multiply across here. So it's going to give us 12/49. And so if we were going to play this game of pulling marbles out, I have a 12 in 49 chance of pulling a red marble, putting it back in, and then pulling a green marble out. So I have probably, if I'm going to do some really quick math here, I'm going to say that the probability of this event happening, I have about a 25% chance of this actually happening. And so the percentage, I'm going to estimate to be about 25%, or 1 in 4 chance of pulling off this game here. But let's take a look at example number 2. So it's very similar, except the key phrase is going to change here. And so we have a bag that has the 4 red marbles in it and 3 green marbles. So what's the probability that I'll pull the red marble, and this time I'm not going to replace it, and then I'm going to pull a green marble out. So when we do not replace it, this is going to be classified as a dependent event. And let's go ahead and take a look at the math with this. So the probability of pulling a red, we start with 7, and there are 4 red marbles. And so that fraction stays the same because we start with 7. This time, when we're talking about the green marble here, the phrase "do not replace it" is going to come into play. Because if I'm going to pull a green marble out after the first one, I only have 6 marbles left. So in a "do not replace" situation, put a star next to that, because it should be 1 less, because I took that marble out and I'm not replacing it. But then my numerator stays the same here. I have 3 green marbles, and so this fraction is going to be 3/6. Or to simplify it, you have a 1/2, you have a 50-50 shot at it. You have the fraction 1/2 for my green marbles. And then let's go ahead and do the probability of this. So the probability of pulling a red marble, and then for when we do a probability, we're going to be multiplying. And then the green marble was 1/2. Let's go to multiply these fractions together now. So 4 times 1 is 4, and 7 times 2 is 14. So I have a 4 in 14 chance of this actually happening. So to find the percent, I can do the numerator divided by the denominator. That gives me a decimal. The decimal times 100. I actually have about a 29% chance of this happening. And so the difference between the two is between example 1 and example 2. Example 1, I put the marble back in, and it kept the denominators the same. With example number 2, I took the marble out and I kept it. And so it affected the second event, making it dependent. I'd rather play game number 2 because I actually have a little better chance of winning.